In this video, we're going to take a look at metallic bonding, which is the type of bonding you get between metal atoms, and we'll see how this gives rise to the characteristic properties of metals. Then lastly, we'll consider how alloys differ from pure metals. To recap, we've already seen that metals bond to nonmetals through ionic bonding, and that nonmetals bond to other nonmetals through covalent bonding. Now we turn to how metals bond to other metals, which we call metallic bonding. If we think of a solid metal, it basically consists of a giant structure of atoms that are arranged in a regular pattern. In this picture, we've shown each atom surrounded by the electrons in its outermost shell. When all these atoms are together in a metal though, they actually give up these outer shell electrons and share them with all the other atoms in the metal. This means that the atoms will all become positive ions, because they've lost negative electrons. And because those electrons are now free to move about, we call them delocalized electrons. So there will now be loads of strong electrostatic attraction between the positive ions and the negative electrons. And it's these forces of attraction which hold everything together in a regular structure. So we call this metallic bonding. This gives the overall metal strength, and means that most metallic structures have high melting and boiling points, so are solid at room temperature. They are also good conductors of electricity and heat, because the delocalized electrons can carry electrical current and thermal energy throughout the structure. Another important property is that metals are malleable, which means that they can easily be bent or hammered into shapes, for example into thin sheets. This can be a bit confusing because we think of metals as being strong, and in many ways they are. But the fact that metals have such a regular structure means that the different layers can slide over one another. So they're not quite as fixed as you might have thought. At least that's the case for pure metals. If we want a harder metal that won't bend so easily, then we can make alloys, which contain two or more different elements. We make these either by mixing together two different metals, or sometimes a metal and a nonmetal. And we generally pick elements that have different sized atoms. The reason that this helps is that the combination of different sized atoms disrupts the metal's regular structure, and means that the layers can no longer slide over one another, making the alloy much harder than pure metal. In our example here, we've shown steel, which is made up mostly of iron, but also contains 1 to 2% carbon. It also sometimes contains chromium, manganese, or vanadium, depending on which properties we want it to have. And this gives it the strength that it needs to be used in things like cars and planes.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.